stereochemistry of 6-member rings. So the 6-member rings are more stable than 5-member ring. It was proved by Sasse in 1890. Okay. In non-planar structure or Hooker structure of cyclohexane, the valence bonds of all carbons are at tetrahedral angle. That means 109 degree to 28 degree to each other, and which are therefore free of angle strain. Which form is free of angle strain? So this chair form. See here. This chair form is free from angle strain. Why? Because each carbon attached with hydrogen tetrahedral angle. Okay. So here sp3 hybridization. So carbon attached with different hydrogens and different carbon tetrahedral angle. So therefore tetrahedral angle so is free from angle strain. Now it is a chair form of cyclohexane. So labeling first 1, 2, 3, 4, 5 and 6 this way. This hydrogen attached with this carbon atoms in cyclohexane ring. Now here I am displaying with this HA and HE. This HA means axial hydrogen and HE means equatorial hydrogen. So how can we explain this chair form and its axial and equatorial hydrogen? So see here. In this structure, this axial above, this axial below, axial above, axial below, above, below. So this way axial in alternate manner, above and below, above and below, this way. Similar way equatorial, equatorial below, above, below, above, below, above. So this way equatorial also arranged in cyclohexane ring. So this way you can see here, this hydrogen axial, this axial, again this axial above, this axial below, again this axial above, this axial below. Same as equatorial, below, above, below, above, below and above, equatorial hydrogens. So this way you can explain equatorial and axial position of hydrogen in cyclohexane ring. Here also given Newman structure of the cyclohexane ring for chair form. So in chair form, so first start with this first carbon, first, second, third, fourth, fifth and sixth. You know, you are familiar with Newman structure. So in first position, okay, now this position it is axial, equatorial, axial. Similar way, axial, equatorial, axial, equatorial, axial, equatorial and axial. This way arrangement of hydrogen in Newman form or Newman projection structure. Okay, and here all the hydrogens are 109 and 28 minutes. So therefore it is a stagger form. Okay, arrange different stagger form. Okay, so that means very less interaction between these two hydrogens. Now chair form is mobile form because which can be distorted into variety of shapes like boat form, twist boat form or half chair form, etc. So therefore this chair form is called mobile form. When the bottom part of the chair form is bent in upward or the bent in downward direction, the chair form is transformed into boat form. Now boat form, when fourth carbon is bent in upward direction, so this boat form or chair form is converted into boat form. Similar way, when first carbon of this chair form bent into downward direction, so this it is converted into boat form. But this structure is more preferable. Here, this chair form is free from angle strain and bone opposition strain, so therefore it has less energy and more stable, and it is point minimum in energy diagram at point A. During transformation, some angular distortion is required because several bonds have to be rotated at the same time. But when chair form convert into boat form, the boat form of cyclohexane molecule has no angle strain. That means bond form is also free from angle strain. Okay, only angle distorted, but is free from angle strain. But it has higher potential energy, and it is described in energy diagram at point D. And this higher potential energy due to bond opposition strain. Bond opposition strain. Now, bond form, there is a bond opposition strain involving the 4 pair of hydrogens at the site of the bond, a pair of upper side and downward side. This way, upper side and downward side. Okay, just interact with each other. So therefore, it is create a bond opposition strain. Okay, you can also see here the Newman projection structure of this bond form. So first carbon, second, third, fourth, fifth, and sixth. Now here, this circle means rear carbon and its hydrogen. It's completely eclipsing with front carbon and its hydrogen. Okay, so you cannot visualize this rear carbon and its hydrogen. So therefore, it is eclipsing. And due to this eclipsing, what happened? Interaction between this hydrogen. So bond opposition strain is due to this eclipsing structure in bond form. Here also in upper hydrogen, the distance between this upper hydrogen is 1.8 angstrom. So it is very close, and this hydrogen is called flagpole hydrogens, and the interaction between this hydrogen is called flagpole interaction. So there is a strain mainly due to a pair of top hydrogens which are about 1.8 angstrom apart, while the sum of van der Waals radii of 2 hydrogens is 2.4 angstrom. That means when hydrogen molecules, the distance between hydrogen molecules is 2.4. Okay, and distance between 2 hydrogen in bond form is 1.8. So it is less as compared to in hydrogen molecule. So therefore it is very close. So more interaction, more repulsion. So therefore reduces its stability and increasing its energy. So therefore it is also called bowsprit flagpole interaction. Okay. The carbon-carbon bonds are exactly eclipsed. Thus there is a significant torsional strain or bond opposition in the molecule. Okay. You can also say torsional strain or bond opposition strain. Both are same. Thus, repulsion in sigma electronic cloud of this hydrogen result in instability of bond conformation. This way you can explain instability of bond form of cyclohexane.